Aparna. I work with Zesmani based out of India, and today I'm going to talk about clean code. Clean code, while the term itself might seem to be very intuitive, what is clean code? It must be good, well written, good quality code. And by quality, I mean the inherent quality of the code itself, not the quality of the product that the software uh, is actually built for. While the term itself is fairly intuitive, it's surprisingly hard to have a set of guiding principles for what is clean code and to actually codify that as a set of recommendations. We have such a plethora of technologies. We have front-end tier, back-end tier, GoLang, Java, Node, Node Express, Next.js, Loopback 4. It's a great problem to have, but it's with this rich choice of software frameworks and tools. The problems developers face is what exactly does it mean to write good code, given that I could be working on React or Node or Java. So this talk is based on a book by Bob Martin, and this book was actually written a good 10, 12 years back. But the fundamentals and the principles of code, um, clean code and good quality code that is discussed in this book is like kind of universally and timelessly relevant. This talk aims to capture some of the uh, major points of the book, the major recommendations of the book. So here we go. What is the measure of code quality, right? When you look at code, when would you say and how would you say it's good quality? Well, there are tools like Sonar Cube right now, which can measure the cyclomatic complexity of code. They have a set of parameters with which they assess and they can give you a report. There could also be other metrics, right? How many functions you have, how many classes. But Bob Martin has an interesting take on it. Let's take a moment to see this. Two rooms, right? Which room do you want to be in? I'm sure the left one. That's like the quality measurement, WTFs per minute. We want to get as few as possible. Anyway, this is starting on a lighter note. We're gonna do a slightly more serious job of defining good quality code. So here's what we will do to get started. What do we do when we code, right? We're going to watch a software engineer coding, right? Watch or like see a transcript of what they're doing. Lena has been assigned to fix a bug. What does she do? She's fairly new to the team. So she's opening the code base in her favorite editor. There are setup issues, some dependency error, something, the build is failing. Now she needs to ask her team members, but they seem to be busy. So she's waiting. This can happen in the best well documented onboarding scenarios. But then finally somebody is available and they tells us, oh, by the way, I'm so sorry, I forgot to tell you there is a git stash. We have changed some environment, local environment variables. Just update that. But now the project is finally building. Right now she's looking at the code structure. The first thing you do when you want to fix a bug is to, of course, reproduce it. Right? She's trying to do that. She's opening a few relevant files. She's scrolling up, scrolling down, checking with some other files and other packages, finding it a bit confusing. Finally, she identifies the part of code that could be a problem. Now she's scrolling up to see how a variable that is getting used is getting initialized. Two functions, get all. What do I change? Again, I need to ask. People are busy. I'll have to wait. Meanwhile, she tries to do something else. Then she comes back. Then she finally decides, okay, I have to set up like a line by line debugging to see how this is working. Finally, the debugging worked. She was able to identify the problem, but how do I fix it? Um, Oh, by the way, a common library needs to change. So now she opens the common library code base and then probably the cycle repeats. A bit of a drama here. Fix is gone to QA. There is a bug because get all was not changed. She changed only get. Um, okay, what did we see in this little, life of a day in the life of a software engineer? Reading code is the predominant activity. If we go back, how much time is Meena actually spending coding? Probably it was maybe one line, just a few minutes, where she was actually typing out something. The rest of the time, we can see that she's trying to understand, she's trying to read, she's trying to look, she's trying to grasp, she's not, waiting for others. Reading is the predominant activity. Reading code should be made easy, even if writing is hard. And making it easy to read means making it easy to write. So this is like the cycle of like great code. It's easy to read, therefore it's easy to write. You take pains in writing, make it easier to read. The easier it is to read, the easier it is to write. And when it is easy to write code, great things happen. It's also one point which is my observation and my experience all these years is we tend to sort of underestimate how to what extent software engineering is a social activity, right? We tend to think of software engineers as like, okay, nerds sitting in a corner, putting on their headphones, lost to the world. Not at all. If you have to develop anything meaningful, anything that impacts people, you will have to you will have to do it as a team, right? Sooner or later, you will have to do it as a team, especially if you want to scale the impact. And when you work in a team, software engineering is one of the most social professions that I have seen. Yeah. Okay, can you identify with any of these? It takes a lot of time for someone new to start contributing. I'm sure a lot of us are familiar. Senior members spend a lot of time helping wade through code. Senior members here would identify. There is an obvious productivity dip with mature code bases, definitely, and rewrites are actively discussed. I really cannot imagine any one of you not identifying with this, and if you do, this talk is certainly for you. What does clean code do? It provides a common set of guiding principles and standards for coding, a better developer experience, and therefore improvement in productivity. We talk about customer experience when we are building software, but unless we are mindful of the developer experience, what does someone looking at your code base who is not in the context of your domain, how how much time does it take for them to get familiar and start contributing? Just imagine you and your entire team out of the current code base that you're handling, the service you're handling. What will happen? What if tomorrow a completely new set of people get started on the code base? There's always a bit of learning curve. It's not instantaneous, but how long would it take them to start being productive? That to me is like the best measure of quality. I mean, if someone new looks at your code base and with just a few hints and pointers from you, um, minimal effort, minimal intervention, is able to understand, get started, have a good experience. It's not that they would have no questions, it's not that they wouldn't have a learning curve, but they have a good experience of getting started on your code base. That is like the North Star. Okay, let's not be like this in not in terms of diversity. Yes, we should all be. It's great to be diverse. We love those teams, but let's not all speak in our own different languages and not understand each other. As software engineers, we need to speak one unified language. There needs to be one unified standard of coding, which is what clean code, the movement aims to bring about. There could be substandards in terms of what is the best patterns in React and what's the best practices of React, best practices of Java Spring Boot. It's there, but Above that is a layer of abstraction which actually clean code aims to address, which is universal. Okay, let's see some code now. We're going to see quite a bit of it. There's a class where, frankly, if I were looking at it, I just wouldn't understand what's going on. There is a variable called the list. There is a method called cells. It's not clear what it does. There is an array list that is being initialized. It's called list one. So what is list zero, list two, list three? I don't know. And then there is something called the list, and that is not list one, but that's being accessed, and blah 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 blah. Right? Um, there are obviously several problems with this code. Right? Let's move on. Yeah, what are these problems? What kind of things are in the list? It's not clear. What is the significance of the zero at subscript? We seem to be very interested in that, right? X0 is equal to 4, and then what is 4? No idea. Not clear from the code. And what is exactly? What is this method? What does it do? What does it return? Is absolutely unclear. Right? Now let's take another stab at it, making it slightly better. There's something like an M game board. I understand now that it is a game board. Flagged cells. Okay, this method has something to do with flagged cells, and it's working with a game board. So I'm assuming it is checking flagged cells in the game board if some way. Status value is equal to flag. This is much more readable. If a cell status value is flagged, I'm interested in that. I add it in my list and I return it. There is something called get underscore cell. There is get cells. Definitely better, but can still be improved. Let's take a look at this. Checkers, game board, get flagged cells. Okay. It doesn't set, it doesn't check, it gets flagged cells, right? And the rest is not that different from what we saw earlier. So what does it do? So these are the guidelines that we can understand based on the examples. Consistent naming. Call one name per concept. Don't have multiple names. Intention revealing names. Game board, flagged cells, get cell, status value, flagged. You know English, you will understand what's going on. Avoid member prefixes. Those are old school, right? No, nobody looks at prefixes. When you become familiar with the code base, you automatically start ignoring the prefixes. And if you're writing good code, your number of member variables should be minimal anyway. You shouldn't have member variables and other variables and not that kind of cognitive overload. Pronounceable names. Everything here is pronounceable. I can pronounce game board, flagged cells. It's not like F cells anymore. That actually sounds a bit okay. Um, Searchable names. Don't call your variables I. If you were to run a search on I, you'll have a problem. A class is a noun or a noun phrase, right? Checkers is a noun phrase. BDS checkers looks like noun phrase, but what is the problem there? Avoid unnecessary context. Maybe BDS is your product that you're developing. So every class in your code base should not be prefixed by BDS. That is unnecessary context. If your service is called BDS, it's assumed that your classes within that service pertain to BDS. Similarly, don't prefix everything, every instance variable or method in your class with like checkers, game board, checkers, flag cells. Not necessary. They are within the class checkers. One word per concept. Yeah. I think to me, naming, if you were to ask me, the one thing which we should all spend a lot of time and effort understanding as engineers, as software engineers, is how to name. Probably everything else is secondary. And all other, of course, clean code principles are some are must read. I would strongly recommend that. If there is something that I would very, very strongly recommend is to go through the first chapter of the clean code book that talks about naming. It will itself lead to like a 50% improvement in code, like whoever is coding. Functions. The first rule of functions is that they should be small. The second rule of functions is that they should be smaller than that. Functions should do one thing and they should do it well. They should do it only. And this is such a pithy statement. Functions should do one thing and they should do it well and they should do that only. A function should be at one level of abstraction. So 2 and 3 go well together. 3 is more technical. I would prefer if we understand 2. The moment we take care of 2, I think we take care of 3. Right? A function is at one level of abstraction. Now let's take this example. It's a bit busy, but in a sense, we seem to be wanting to validate a user who's trying to log in, right? Have this user, check their password, blah blah blah, cryptographer, user directory, find the user. Did you get the user or not? No, you didn't get the user. Okay, you're not even our user. Sorry, can't log in. Then check the password. Get the encoded password of the user, compare it with the entered password, what's happening, valid, not valid, do some things based on that. Fair enough. I mean, with like 1 minute of some reading, you can understand what's going on. But there are problems with it. What are those? One thing in an interactive session, this is the interesting part. I can wait for people to tell me what's wrong. But probably here, I'll just wait a moment so that you can think what could be the problem and then come back to it. Okay. So, based on even just the principles that we have read so far, right? Just the previous slide, the naming section, and what we have read as the principles of good functions. This function is not doing one thing. Very obviously, it checks for the password. If it is an admin, it has to do something, publish a message. And then session.initialize. Who knew? We only called this method to check password. Check this user's password, tell me if it is valid or not. That's all I'm expecting you to do. That's what you're saying you're going to do. But no, there is a session.initialize. So I call this, and there is the serious side effect of the user session being initialized, and I have no idea. And then that goes on to do more message publishing, right? The cleaner approach would be for check password, right? Validating of user password to do only that. Now see how simple it is. Getting the user, getting the encoded password, comparing it true, false. That's it. Simple. And in the main function, it is the caller's responsibility to do whatever else they want. Now that you've validated the user, you know this is a valid password entered. Then go on, initialize the session for the user, publish whatever message you want to. But we probably functions is all about understanding what is your problem and what isn't. The moment you take on more than what really is your problem, there's trouble. So if we are very even obsessive about this point, that is not my problem, that goes a long way in that principle of one function, one thing. More recommendations: encapsulate conditionals and functions. Just see this is valid insertion. I'm doing a lot of things, but there is some check that I want to do. Is it valid? There is a lot going on. Available column greater than one, number of items, grid pinner, blah blah blah. Quite a few checks, and then finally it tells you is it valid or not. If this was not a separate function, if it was a part of insert check, would this have been readable? Would we have understood what is going on? In fact, many developers, you don't want developers to go into details when they are actually reading functions. They need to understand at a high level of abstraction what is going on, and then go into lower level of detail and abstraction if they want to. If I just want to understand how a chip is inserted, I just need to read these lines of code. That's it. If I'm interested in how the validation is done, if it's important to me at this point, I will go on and read it. Otherwise, I won't. And I think this example clearly tells us what the levels of abstraction is all about. Validating the insertion in the insert chip function is two levels of abstraction. Putting it in a separate function is putting having two different functions for two levels of abstraction. Insert chip is at a higher level, is valid is at a lower level. Good one. Step down rule. A code reads like a story. To handle an event, I first have to process an event. Then I have to raise an event. To process the request, I have to create a request. And then I have to call an API to get the response. Then I process the response and then I'm done. To raise an event, I so on. Right? So handle does a process request and raise event. To handle an event, you need to process a request and raise. So when code reads like that, to do this, you need to do this and this in order to do that. And this code is exactly like that, right? To me, it's reading like a story. Step one, do A and B. To do A, you need to do A, B, C. So very beautiful, very well written. Naming functions. You know you are working on clean code when each routine turns out to be pretty much what you expected, right? And though this might seem to be a bit imprecise definition, I think this captures it. Uh, no one can put it better, frankly, unless you want to be like very technical and mathematical, which defeats the purpose of really connecting with everyone. You said you're getting flag cells. You got me the flag cells. It didn't do anything. You said I'm checking user password. You checked the user password and told me if it is correct or not. That's it. Nothing else. So whatever the cleaner options that we've seen so far, those actually the reason they were clean, those functions were clean is because they were doing what we would expect them to do based on their name, as simple as that. And that's ultimately what it's about. I think there's a bit of a, I'm using two terms, functions and methods. Function is more technology independent, right? Function is a block of code that accomplishes something, whereas method is more specific to object-oriented programming, where a method is a member of a class that helps us that processes the instance variables in some way, so that the instance variables are not exposed. Okay, don't be afraid to make a name long. A long descriptive name is better than long descriptive comment and a short enigmatic name. Very, very, very true. Don't try to compromise on your name and write a comment in explanation. That comment has to translate to a function name. It's okay if it's long. People can deal with long names. It is not at all uncommon that hunting for a good name results in a favorable restructuring of the code. Wow, it does. I can tell you it does. When you start thinking about, hey, what should I name it? Every time we've had a problem naming something, we've had a problem naming even a service, it is because that service did not have a clearly defined responsibility. That class did not have a clearly defined responsibility. And when we struggle to define or struggle to name something, that is like a symptom of something more serious. Things, entities that are at a single level of abstraction that do one thing, name themselves. You don't have to struggle. So the problems that you have at hand by how much time you're taking to name something. Surprising how that is true. If a function has more than three arguments, it is very probable that a function is doing more than one thing. Yes. Passing a boolean as a parameter is a direct sign that the function can be broken down in two different functions. I mean, this is so simple and so beautiful. Let's see some examples. Print area boolean. Is circle else do something else? No. Print circle area, print square area. Print circle area. There is absolutely no confusion, right? It's going to calculate the area and it's going to print it. Print square area. And I don't think it's misleading that it's going to calculate it, because you're actually passing the radius here. And It's not changing its input in any way, right? So it's not having a side effect either. Dependent functions. Initialize queue, create queue, start. Wait, how is initialize queue called? Oh, it's called in create. Now, who's calling create? Okay, start is calling create. It's not easy. Now just see a simple change in the order. Start. Start calls create. Create calls initialize. We need to strive to create this ease, just this change, right? There would be no problem compiling this code. There might be no bugs in this code. It would pass probably all the checks also. It would go to production. Your product might be a success, but someone who is reading your code is going to have a tough time. And you have not done justice as a software engineer unless you've ensured developer experience along with user experience. This creates a natural flow. The readers will be able to trust that the function definitions will follow shortly after their use, right? Building that trust. Create queue. Okay, I'm sure I'm going to get create queue uh, when I see the next line I read. This also keeps the reader to get the full context of the code without scrolling back and forth from column to column. True, right? Code formatting. This might be like, okay, formatting. Why do you even need to check? Why do we need these rules? Doesn't our editor take care of it? Prettier takes care of it. But we need to know what to tell Prettier, right? Associate things that are strongly related, dissociate things that are more weakly related. Simple enough. Now, I understand what's going on. I know what's a quadratic equation. I know how to find roots of a quadratic equation. Root 1, root 2, find out the determinant. But unless you know the math, this code is going to be daunting to anyone reading it. It's really hard, right? Not easy on the eye. Check this one. Now it's nice. Oh, there's a function called determinant that is getting called with ABC. I do a square root of the determinant, then minus b minus that divided by 2 into a. Minus b plus square root of determinant divided by 2 into a. It's the spaces, the horizontal formatting, right? This principle. Associate things that are strongly associated and dissociate the others. Isn't it's working beautifully? Just this level of intervention can create 2x the experience that your uh, developers reading your code would otherwise have. Horizontal alignment. This looks clean, but is it? No. Your eyes are drawn to socket input and request progress. The type is kind of getting sidelined. You're looking at S and input, but you're not looking at what it is assigned to. We don't need to do this, right? It's sort of drawing attention to parts of the code that really pattern that should not be drawn attention to, and our we should trust the default settings of our um, um, formatting tools for this, right? It should look like this. And when you have a problem, when you feel that, hey, something is wrong here, I mean, it's just too much, private, protected, it's not that easy for me to read. The answer is not this. The answer is not to create spaces, but the answer is to think more about uh, is your class really doing one thing? Or is it doing too many things and there are too many variables and it's hard to even read through them, right? Vertical openness. Not nice. I don't need to tell you why. Beautiful. Package, import statements. There is a class, there are static variables. Then there are the methods. There is a constructor, sorry. Then methods. I have no problem in understanding this. Vertical density. Reporter config 1 or reporter config 2, which is better? There is a comment, the class name of the reporter listener, properties of the reporter listener. Excuse me, like, what are these comments for? They're not making sense. What should I see? What should I see first? What are the member variables, methods? It's not clear. But let's look at the second definition. Class starts, instance variables are listed, method start, right? Simple. That's what we need. Each blank line is a visual cue that identifies a new and separate concept. Tightly related code should appear vertically dense. Variables should be declared as close to their usage as possible. If you're working on a team, then team should agree to a single set of formatting rules and all members should comply. That's exactly what we're doing. I think formatting is something that teams do insist we do. So I do insist that everybody in my team has the same prettier formatting rules. It's a nightmare to review code otherwise. But blank lines, what are the best practices in terms of density, openness? That's something I think a formatting tool cannot impose that easily. Right? Comments, my favorite section. Let's see what's happening here. Oh, check to see if an employee is eligible for full benefits. Got it, got it. And then something happens here. So there is English and then there is code. The English is what is clear. Right? It's telling you what is actually happening. And then you're supposed to assume that this code is right and the following code does exactly what the comment says. Both are wrong assumptions. Right? Somebody might have forgotten to date the comment and somebody might be reading the code or they might skip reading the code because they think the comment is right. Let's not add comments to explain our code ever, right? It should be only like the rarest of the rare case. Check this out. Employee dot is eligible for full benefits. This is English. I don't have a separate English statement. My method itself is clear, plain English, right? Solves the problem. Does the module from global list depend on the subsystem we are part of? What is the problem here? This is what something we will see later is called a train wreck. One line of code is overloaded in terms of the number of things it does. Get dependent subsystems, dot contain, subsystem dot get subsystem. Whereas, see the second definition. Module dependency. Oh, okay, fine. Get all the modules. Our subsystem. Oh, subsystem module dot get subsystem. Dependencies dot contains our subsystem. Much clearer. What are we saving by not writing these three lines of code? There's absolutely no impact in terms of how efficiently it is compiled and stuff like that. And this could end up being if there are variable initializations that are not used, that's definitely a bad idea. But that's not the case here, right? Module dependency, dependees is used, subsystem is used. So why explain your code when you can break down your code in a simpler fashion? Oh, this is really nice. This is cool. There is day of month, right? What else could day of month be? It's the day of the month. And the comment says day of the month, right? I think I don't even need to explain this. I have seen comments like this. Honestly. What are some of the good comments? Yeah, this helps me that I should generally avoid running this test case, not make it a part of my test suite before building or something like that, right? Mandatory test passes before building, probably excluded from there. An emphasis of something that is not very clear immediately from the code. This is acceptable comment. That hey, don't this trim is not just like just another thing that we're doing, It's important because it removes the starting spaces that could cause the item to be recognized as a separate list because probably we are splitting it based on space or something and white spaces. It could happen. Comments are I have a rule of thumb. I don't write comments. And if I feel I have to write comments, it's a symptom of my code which is not clean. Objects and data structures. Um, Now, here we will touch upon just two major concepts. Objects and data structure is a huge topic. Those are the fundamentals of OOPS. And in the interest of time, the two things which are not that immediately evident when we are building with OOPS. Let's just take this. It's just a very typical Bojo. I have a class, fuel tank capacity, fuel in gallons, get set. Nice. I got a couple of member variables. I'm exposing them through get and set. I might even make these private. And cool, I have my class right there, and I have abstracted, I've encapsulated, I've abstracted, I've done all that. Great. But abstraction in a class is more than making your member variables private and adding getters and setters. Think of what is the abstraction that your callers need. In this case, I don't want people to be arbitrarily setting my fuel tank capacity, right? Get percent fuel remaining. That is what people are interested in. It doesn't have to be, we don't care. Are we measuring it in gallons? Are we measuring it in liters? Doesn't matter. I just want to get the percentage of fuel remaining. I have just 10% remaining, right? So then I have a problem. I have to refuel pretty quickly. Update fuel for distance driven. This could be a regularly called method, and it keeps updating like how much fuel is remaining in gallons. So when we say abstraction in OOPS, this is what is interesting. This is what it should be instead of just adding getters and setters. I think how data should be exposed. Yeah, data and object anti-symmetry. Now, this is very interesting. Data versus object. Data. What's a class? What's encapsulation in a class versus what is data? Let's take an example. I have three shapes, and I have a geometry class that calculates the area. Depending on the shape, it calculates the area in different ways. Every shape has some basic attributes: square, side, rectangle, height, and width. And depending on the shape, you'll have different attributes. This is one way of achieving my purpose, right? I have some shapes, and I have a geometry class, and you can call the area uh, method with an instance of your shape. It's going to give you the area. Nice. Good. Then the more familiar, I have square, I have rectangle, I have circle, all implementing shape, all overriding area, and all calculating area in different ways. Right. Now, is there something like B is better than A? Uh, Generally, I mean, when I started with Oops, I thought this was the only way. I mean, this is what we need to do. And I didn't even like, I thought like, this way of doing things, of not declaring interfaces and having classes and declaring another class that does some processing, I thought this is not given, this is not done, right? This must be some sort of bad idea. But it was a revelation to understand that it depends upon what is the kind of problem that you're solving, what are the kind of changes that you foresee in your system. Now just imagine for a moment that uh, I have a new shape that I want to add, right? I'll add a class for that shape, and I will have to change area and calculate area for that shape differently, right? Not that easy here. Whereas here, if I have to add a new shape, it's so simple. I implement shape, I override area, I'm done. But now consider if I want to start calculating perimeter. I have to change the shape interface, add a perimeter method. For every class that implements shape, I have to override perimeter. Whereas here, if I have to add a perimeter method, I just have to change geometry and I'm done. Nothing else is impacted, right? So think of what makes more sense. That's what this slide is telling us. Objects hide their data behind abstractions and expose functions that operate on that data. Data structures expose data and have no meaningful functions. This is like opposite, right? Over here, this is called a class, but this is actually a data structure, right? Here I have a data structure approach versus here I have a class approach. What do you want, right? And think of your use case before you make a choice. Procedural code makes it easy to add new functions without changing existing data structures. Example 1. Object-oriented code makes it easy to add new classes without changing existing functions. Example 2. Now, here, what is this called? It's called a train wreck. Do not write train wrecks. As long as you don't initialize variables, you don't lose. You can break it down into simpler lines. First, get the options. From the options, get your scratch directory. From the scratch directory, get absolute path. 2 is so much more readable, so easy on the eye versus 1, and that does not give us any kind of performance benefits. What is the law of demeter? Right? The method of a class should only call the methods of these, right? Don't call any method except these. Call a method of the class in which you're initialized in. Call a method of an object that you have created. Call a method of an object passed as an argument to you, or call a method of the object held as an instance variable in the class. Nothing else. And once this law of Demeter is confirmed to, we have we solve the problem of unexpected method calls, unexpected function calling. Hey, by the way, how did this particular method do this change? No confusions. It would have been possible to do this change only if one of these four cases was true. Don't just code, clean code. And thank you to the original Bob Martin.